Welcome to our exploration of Python lists. Lists are one of Python's most versatile and powerful data structures. They're ordered, mutable collections that can store different types of data. Whether you are managing shopping items, processing datasets, or building complex applications, lists are your go-to tool. A list in Python is an ordered collection of items. Think of it like a container that can hold multiple values, each accessible by its position or index. Here's a visual representation of a list containing fruits. Each element occupies a specific position, and we can access any element using its index number. Lists have 4 key characteristics. They're ordered, meaning items maintain their sequence. They're mutable, so we can modify them. They allow duplicates, and they can store mixed data types like numbers, strings, and even other lists. There are several ways to create lists in Python. Let's explore the most common methods. We can create empty lists using square brackets or the list constructor. Lists with initial values use comma-separated items in brackets. The list constructor can convert other iterables like strings or ranges. List comprehensions provide a powerful way to create lists programmatically. Indexing allows us to access individual elements in a list. Python uses zero-based indexing, meaning the first element is at index 0. Here we have a list of programming languages. Notice how each element has both a positive index from left to right and a negative index from right to left. Positive indices start from 0 and go left to right. Negative indices start from -1 and go right to left. This dual indexing system makes it easy to access elements from either end. Remember, accessing an index that doesn't exist raises an index error. Index 0 accesses the element Python. Index 1 accesses the element Java. Index -1 accesses the element Go. Index -2 accesses the element JavaScript. Slicing extracts portions of lists using the colon notation. It's incredibly powerful for getting sublists without modifying the original. Let's use this list of numbers from 0 to 9 to demonstrate various slicing operations. The slicing syntax is start: stop: step. When start is omitted, it defaults to the beginning. When stop is omitted, it goes to the end. Step determines the interval. Slice 2 is to 6 produces subset with result 2, 3, 4, 5. Slice 4 produces beginning with result 0, 1, 2, 3. Slice 6 produces ending with result 6, 7, 8, 9. Slice 2 produces evens with result 0, 2, 4, 6, 8. Slice -1 produces reverse with result 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Lists are mutable, meaning we can modify them after creation. Let's explore different ways to add elements to lists. The append method adds a single element to the end of the list. Let's see this in action. We append the element D to our list. Besides append, we have insert for adding at specific positions, and extend for adding multiple elements. Insert takes an index and value, placing the new element at that position. Extend adds all elements from an iterable to the end. The plus operator creates a new list, while plus equals modifies the existing list in place. Just as we can add elements, we can remove them in several ways. Let's explore the different removal methods. Remove deletes the first occurrence of a value. Pop removes and returns an element, defaulting to the last item. Del removes elements by index. Clear empties the entire list. We can also use del with slicing to remove multiple elements at once. Let's visualize the pop method. Pop removes and returns the last element by default. The pop method removes E and returns it. Since lists are mutable, we can change individual elements or entire sections using index assignment and slice assignment. We can modify single elements using index assignment. Slice assignment lets us replace multiple elements. Even with a different number of items, lists can be sorted and reversed in place. Modifying the original list. Let's modify the element at index 2 from 78 to 82. Lists come with many built-in methods for common operations. Let's explore the most useful ones. Here are essential list methods. Count finds occurrences. Index locates elements. Copy creates duplicates. Sort and reverse modify in place. While len, max, and min provide useful statistics. These examples show methods in action. Notice how sort and reverse modify the original list. While copy creates a new list, the in operator checks membership without needing a method call. List comprehensions provide a concise way to create lists based on existing sequences or ranges. They're more Pythonic and often faster than traditional loops. The traditional loop approach requires multiple lines. List comprehensions do the same in one line. We can add conditions to filter elements, work with any iterable, and even create nested combinations like coordinate pairs. Let's see how lists solve real-world problems across different domains. In data processing, lists help analyze sales figures. We can calculate totals, averages, and extremes. List comprehensions filter data, while sorting identifies top performers. For inventory management, parallel lists track products and quantities. We can add new items, remove discontinued ones, and identify low stock using zip and list comprehensions. To use lists effectively, follow these best practices for performance and readability. Use list comprehensions for clean, readable transformations. Append is more efficient than concatenation for single elements. Extend works well for multiple elements. For frequent front operations, consider dec from collections. Use enumerate when you need both indices and values. Avoid repeated concatenation and never modify a list while iterating over it. Here are practical examples. Enumerate is cleaner than range with len. Build lists efficiently with append. Or even better, use list comprehensions. Avoid repeated concatenation as it creates new lists each time, which is slow. Let's recap the key concepts. Lists are ordered, mutable collections perfect for storing sequences of data. They support zero-based indexing in both directions. Slicing provides flexible data extraction. Rich built-in methods handle common operations. List comprehensions offer elegant solutions. Together, these features make lists essential for data processing and algorithm implementation. Lists are fundamental to Python programming. Whether you're processing datasets, implementing algorithms, or building applications, mastering lists will make you a more effective Python programmer. Practice with different scenarios. Experiment with list comprehensions. And remember, when in doubt, lists are often the answer. Thank you for joining this deep dive into Python lists. Keep practicing, keep exploring, and remember, every expert was once a beginner. Happy coding!